All these resolutions ultimately lead to the contradiction, confirming that the negated goal, Aditya not feels relieved, is false. This means our original goal, Aditya feels relieved, is true. Hi there, and welcome to this exciting video on how to solve logical queries using resolution in artificial intelligence. If you have ever wondered how AI systems like chatbots or reasoning engines answer complex questions using logic, you're in the right place. In this video, we will break down one of the most powerful methods in AI, resolution in first order logic. By the end of this video, you will not only understand how resolution works, but also be able to apply it step by step to solve logical problems. We will start by understanding what first order logic, that is FOL, is and why it's crucial in AI reasoning. Then we will dive into resolution in FOL, what it is, how it works, and why it's such a vital tool. After that, I'll guide you through the steps in resolution method, and we will finish with a detailed example to see how everything comes together in practice. So get ready to explore the foundations of logical reasoning in AI. Let's begin with the basics. What is first order logic? First order logic, or FOL, is one of the most important tools in artificial intelligence for expressing and reasoning about the logical statements. But what exactly it is? FOL is a formal system that allows us to express logical statements using quantifiers, variables, and predicates. It provides a structured way to describe relationships between objects and reason about them logically. Here are the key building blocks of FOL. Predicates. These describe relationships between objects. For example, loves x, y means x loves y. So loves is a predicate here. Quantifier. This allows us to make statements about groups of objects. Logical connectives. Logical connectives include and, or, not, implies. Domain of discourse. This defines the set of objects we are reasoning about, for example, people, numbers, or items in knowledge base. Now that we understand FOL, let's move on to one of the most powerful proof techniques, resolution. This method plays a crucial role in automated reasoning and is widely used in artificial intelligence. Resolution is a proof technique in FOL that relies on contradiction to derived conclusions. Instead of directly proving a statement, it assumes the negation of the statement and works towards a logical contradiction. Resolution works by combining complementary literals such as A and not A from two different clauses. This process produces a new clause, simplifying the knowledge base step by step. By repeating this process, we eventually derived a contradiction if the negation of the query is false. Resolution is central to AI reasoning because it's a sound and complete method. If a conclusion can logically follow from a set of premises, resolution will find it. Now that we have covered the basics of resolution, let us walk through steps involved in applying the resolution method to solve logical queries. The first step in resolution method is to convert our first order logic statements into CNF. CNF stands for Conjunctive Normal Form. CNF is a way of writing logic that breaks down statements into conjunctions of disjunctions, basically ands of ors. There are the key substeps in this process. First is to remove implications. Standardize variables. Ensure that each variable in the expression is unique to avoid confusion. Columnize extensional quantifiers. Then flatten to disjunctions. Break down all the logical expressions into odd terms for ease of processing. Next, we negate the goal or the conclusion we want to prove. We assume that the opposite of what we are trying to prove is true and try to derive the contradiction from this assumption. Once negated, we add this new negated statement to our knowledge base, which help us for resolution. Now we begin the actual resolution process. The resolution rule is simple. Select two clauses that have complementary literals. Complementary literals are terms that can cancel each other out, like A and not A. Resolve these complementary literals to form a new clause which combines the information from the two clauses while eliminating the complementary literals. Repeat until contradiction. Resolution continues until a contradiction is found. This is ultimate goal. Each time we apply the resolution rule, we get a new clause. We repeat the process of resolving pairs of clauses until one of two things happens. 1. We derive an empty clause which represent a contradiction, or if no contradiction can be derived and query cannot be proven. Once we reach an empty clause, it means the negation of our goal leads to a contradiction and therefore our original goal must be true. Now let us put everything we have learned into practice with an example. We will use the resolution method to prove a logical statement using a set of premises. Here are the statements in our knowledge base. First statement: everyone who studies hard or is naturally talented passes the exam. Second statement: if someone passes the exam, they either celebrate or feel relieved. Third statement: Aditya does not study hard but is naturally talented. Fourth statement: Aditya does not celebrate. Given these premises, our goal is to prove that Aditya feels relieved. We will now proceed step by step to apply resolution method and see if we can derive this conclusion. Let's break down the process to prove that Aditya feels relieved. Now that we understand the resolution method, let's start by representing statements in our knowledge base using the first order logic. Step 1. Represent the knowledge base in FOL. We begin by understanding each of the premises in the problem into FOL. Here are the statements from the knowledge base. First statement: everyone who studies hard or is naturally talented passes the exam. So this we can write with the help of three predicates: studies hard, talented, and passes exam. So we can write it in FOL as for all x, if x studies hard and x is talented, then x passes exam. Second statement: if someone passes the exam, they either celebrate or feel relieved. This statement can be represented with three predicates: passes exam, celebrates, and feels relieved. So this statement can be written as for all x, if x passes exam, then x celebrates or x feels relieved. Third statement is Aditya does not study hard but is naturally talented. We can use two different predicates: studies hard and talented. So this statement can be written as not Aditya studies hard or Aditya talented. Fourth statement is Aditya does not celebrate. This is represented as a predicate celebrates, and this statement will be Aditya not celebrates. Our goal is to prove that Aditya feels relieved. That is, feels relieved Aditya. Negated goal. To use the resolution method, we first negate the goal. So instead of proving that Aditya feels relieved, we will assume the opposite. Aditya does not feel relieved. With these FOL statements, we are now ready to apply the resolution method and try to derive the contradiction from the negated goal. Step 2. Convert statements to conjunctive normal form, that is CNF. CNF is a standardized way of writing logical formulas so that they can be processed easily by resolution method. So let's start with the statement 1. Everyone who studies hard is naturally talented, passes the exam. This we have written as for all x, if x studies hard or x is talented, then x passes exam. So step 1 would be to replace implication. Implication can be written as a disjunction, means A implies B can be written as not A or B. This gives us for all x, if X does not study hard, or X is talented, or X passes the exam. Step 2 is simplify. Apply De Morgan's law to negation of the disjunction. So, the statement would be for all X, X does not study hard, or X is not talented, or passes exam X. Third step is distribute OR over AND. Now we distribute the OR over and the statement would be X does not study hard, or X passes exam, and X is not talented, or X passes exam. Now with this we got two CNF clauses. First clause is X does not study hard, or X passes exam, and second clause is X is not talented, or X passes exam. Now we will go to second statement. Second statement is if someone passes the exam, they either celebrate or feel relieved. So we have represented this in FOL as for all X. If X passes exam, then X celebrates or X feels relieved. Now replace implication. So we will have a statement for all X, X not passes exam, or X celebrates, or X feels relieved. The CNF for this statement is X does not pass exam, or X celebrates, or X feels relieved. Now statement 3. Aditya does not study hard but is naturally talented. So we have represented this in FOL as Aditya does not study hard or Aditya talented. Since this is already in conjunction of literals, we can directly convert it into CNF. So the statement would be Aditya not studies hard and Aditya talented. Then let's see statement 4. Aditya does not celebrate. This is represented as Aditya not celebrates. This is already in CNF. Now let's focus on negated goal. Aditya does not feel relieved. This is already in CNF. Now we have all these statements from the knowledge base and our negated goal in CNF. Let's proceed to apply the resolution rule and start deriving new clauses. Our goal is to prove that Aditya feels relieved. So first we will resolve using clause 1 and clause 4. Clause 1 is X does not study hard or X passes exam. So by substituting X is equals to Aditya, we get Aditya not studies hard or Aditya passes exam. Clause 4 is Aditya not studies hard. There is a common factor in both the clauses, so we will deduce that Aditya passes the exam. Now resolve using clause 3 and this result. Clause 3 is X not passes exam, or X celebrates, or X feels relieved. Substituting X is equals to Aditya, we get Aditya not passes exam, or Aditya celebrates, or feels relieved. Now using the result, previous result, we have Aditya passes exam. Now we resolve on complementary literal. Aditya celebrates or Aditya feels relieved. Now resolve using clause 6 and this result. So clause 6 says Aditya not celebrates. So we resolve on complementary literal. Aditya feels relieved. Now resolve using the negated goal and this result. Finally we have result which says Aditya feels relieved and the negated goal from the earlier. When we resolve these two clauses, we get contradiction. Since we derived a contradiction, we can conclude that the negated goal, Aditya not feels relieved, is false, and therefore our original goal is true, which is Aditya feels relieved. This completes our proof by using resolution method. By systematically applying resolution, we derived a contradiction, confirming that Aditya feels relieved. Now for better understanding, Let's visualize the resolution process for our example using resolution graph. Resolution graph shows how different clauses are resolved step by step to reach the final contradiction, proving our goal. From clause 1, we got statement Aditya not studies hard or Aditya passes exam. Clause 4 is Aditya not studies hard. So resolving these gives us Aditya passes exam. Now from clause 3, Aditya not passes exam or Aditya celebrates or Aditya feels relieved. Resolving this with Aditya passes exam gives us Aditya celebrates or Aditya feels relieved. From clause 6, Aditya not celebrates, we resolve Aditya feels relieved. Now we resolved Aditya feels relieved with the negated goal Aditya not feels relieved. This result is in contradiction. All these resolutions ultimately lead to the contradiction, confirming that the negated goal Aditya not feels relieved is false. This means our original goal Aditya feels relieved is true. The resolution graph provides a clear visual representation of the logical steps involved. Each resolution moves us closer to either proving or disproving the goal. In this case, the contradiction confirms that Aditya feels relieved. That brings us to the end of this video on solving logical queries using resolution in AI. Let's quickly recap what we covered today. We started by understanding the fundamentals of FOL, its definition, key features, and why it's so powerful for representing knowledge. We explored resolution as a proof technique and broke it down into clear and systematic steps. Finally, we applied resolution to an example problem, demonstrating how to logically prove a conclusion step by step. If you found this video helpful, don't forget to give it a thumbs up, share it with others who are exploring AI, and subscribe to my channel for more in-depth content on AI and problem-solving techniques. And if you have any questions or topics you would like me to cover, drop them in the comment below. I would love to hear from you. Thank you for watching. I'll see you in my next video. Till then, be passionate learner, keep learning. Thank you.